When we last spoke, we were discussing the homologous series of hydrocarbons. Please take out your reference tables while you're watching this video. You will need to refer to both Table P and Table Q throughout this video. We last spoke, we were discussing the alkanes that have the general formula CnH2n plus 2. This can be seen in Table Q. So for instance, if you had 2 carbons, then you would have 2 times 2, which is 4, plus 2, 6 hydrogens. So the formula of an alkane could be C2H6. This represents a saturated hydrocarbon, as all the bonds between the carbon atoms are single bonds. All the alkanes end with the ending ane. We looked at a few different alkanes when we last spoke. We looked at methane, which is a 1-carbon alkane. We looked at ethane, which is a 2-carbon alkane. We looked at propane, which is a 3-carbon alkane. Those prefixes, meth, eth, prop, bute, pent, hex, hept, oct, non, and dec, those are all listed in Table P. Today we are going to spend some time talking about the alkenes. These are the second of the homologous series of hydrocarbons that are listed in Table Q. It has the general formula CnH2n.
What is the formula for the alkene that has 4 carbons? If your alkene has 4 carbons, C4, then the number of hydrogens should be twice the number of carbons, H8, C4H8. The alkanes contain 1 double bond. That is why there's a difference between the general formula for the alkenes, CnH2n, and that we learned about the alkanes previously, CnH2n plus 2. This does not mean that all of the carbons have double bonds between them. It means that there is 1 double bond between 2 carbon atoms. Because of the double bond, an alkene is considered an unsaturated hydrocarbon. This is different from the alkanes that had all single bonds and were considered saturated hydrocarbons. The double bond makes the alkene an unsaturated hydrocarbon. What is the smallest possible organic compound in the alkene group? Can you have methane? You can't have methane, and the reason you can't have methane is because you need to have a double bond between carbon atoms. In order to have a double bond between carbon atoms, you must have at least 2 carbon atoms. Therefore, the smallest alkene member is that of ethene. Here is a picture of ethene. Eth is the prefix for 2. Ene means that it is an alkene. And here we have the structure for ethene, which has 2 carbons, C2, and because of the general formula CnH2n, it has 4 hydrogens. So notice that there is a double bond between the 2 carbon atoms, but also remember that carbon must have a certain number of bonds. How many bonds must every carbon atom have? Every carbon atom must have 4 bonds. So since this carbon already has 2 bonds bonded to the other carbon, it must also get 2 more bonds, and those are filled with hydrogens. Since this carbon already has a double bond here, it also needs 2 more bonds, and so therefore those bonds are filled with hydrogens, making the formula for ethene C2H4. What is the name of the next member of the alkene family? What is the formula for the next member of the alkene family? Propene is the next member of the alkene family. Prop, which is the prefix for 3, ene meaning that it is an alkene. So here we have our 3 carbon atoms, and they are bonded to each other, and there is 1 double bond between the carbon atoms. Remember that the alkene doesn't mean that you have double bonds between every carbon atom, just that you have a double bond between 2 of the carbon atoms. Because it has 3 carbons, and the formula is CnH2n for an alkene, it must have 6 hydrogens. let's talk about the placement of those hydrogens. Since this carbon already has two bonds between it and the next carbon, it must have two more bonds, and those are filled with hydrogens. Since this carbon has two bonds to this carbon and one bond to this carbon, it now already has three bonds and therefore can have one more bond, which is to a hydrogen. Since the last carbon here only has one bond, it can have three more bonds, and therefore it is filled with three hydrogens. Now, if you place the hydrogen to the top and to the left, as it's shown in this picture, that's fine. The top and the bottom is fine. The bottom and the left is fine. All those directions are fine. It doesn't matter which ones you chose, as long as there are only two bonds to hydrogens on that carbon. On this middle carbon, since there's two carbon bonds here and one carbon bond there, that's a total of three. You need one more. Here we've placed the hydrogen to the top. If you've placed it to the bottom, that is fine as well. And because it has one carbon bond on this last carbon, it gets three more to the other three directions. Look at these two compounds. They are both three carbon compounds. They both have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 hydrogens. So they are both C3H6. They both have one double bond between carbons. Are these the same or are these different compounds? These compounds are the mirror image of each other, and therefore they are the same. If you look at this compound, you'll see that the double bond is between the first and the second carbon of a three-carbon chain. Here, if you look from the left to right, it looks like it's between the second and the third. But if you look at it from the right to the left, then you have between the first and the second carbon. They are mirror images of each other, and if you were just to rotate this compound, you would get this compound. And so therefore, these are the same compound. Here is a model of one of those two compounds. You can see the double bond between the first and second carbon here, and a single bond between the second and third carbon. If you were to flip this around, now we have a single bond between the first and the second carbon, and a double bond between the second and the third carbon. I didn't do anything. All I did was rotate the compound. And so therefore, you can see that those two compounds are the same, but just the mirror image, or looking at it from a different point of view. What is the name of the next member of the alkene family? What is the formula for the next member of the alkene family? The next member of the alkene family is butene, C4H8. Try to draw butene on your own. Did you get one of these three compounds? Look at each of these compounds individually and compare them to the drawing that you just drew. You should have 4 carbons. You should have a total of 8 hydrogens. Look at where you placed your double bond. Did you place it between the first and second carbon? Did you place it between the second and the third carbon? Did you place it between the third or the fourth carbon? The position of the hydrogens doesn't matter as long as you have the right number of hydrogens on each carbon. So if you place the double bond here, make sure that this first carbon has 2 hydrogens. The second carbon has 1 hydrogen. The third carbon here would have 2 hydrogens, and the last one would have 3. If you place the double bond between the second and the third carbon, make sure your first carbon has 3 hydrogens, your second has 1, your third has 1, and your fourth has 3. The position of the hydrogen, whether it be up or down over here or over here, doesn't matter. Same thing over here. So double check between your drawing and the drawings on the screen and vote for which one you drew. The first one is called 1-butene or N-butene. 1 is because that double bond was placed between the first and the second carbon, starting at the first carbon. So it is called 1-butene, telling you the location of that double bond. It is also sometimes called N-butene or normal butene, putting the double bond in the first position. If you drew the second compound, putting the double bond between the second and the third carbon, that is called 2-butene because the double bond starts at the second carbon and is in between the second and third carbon. So you have a C with 3 H's, a C with 1 H double bonded to a C with 1 H that's single bonded to a C with 3 H's. This is called 2-butene, different from 1-butene, as 1-butene had the double bond between the first and second carbon, and 2-butene has the bond between the second and third carbon. Is there a 3-butene? This was the first compound. This is the last compound. Are they the same or are they different? This is the first compound with the double bond between the first and second carbon of a 4-carbon chain, 1, 2, 3, 4. The last one is this, with the double bond in the third position on a 4-carbon chain, 1, 2, 3, 4. Notice that I didn't do anything to the compound other than rotate it to get those two different structures. Therefore, the two structures are not different at all, but they are the same compound.
Only the first two structures are different structures. The third structure was the same as the first. So the first structure was 1-butene or N-butene with the double bond in the first position. The second structure was 2-butene with the double bond in the second position. And that third structure was really the same as the first structure, 1-butene. Whenever you're naming a compound, please make sure that you count the carbon numbers, putting that double bond in the lowest possible position. 1-butene and 2-butene are examples of isomers. An isomer is a compound with the same formula but a different structure. Both 1-butene and 2-butene have the formula C4H8, but they have different structures.